The name of the topic is called as a operator. Operators. Operators is very important topic. So whenever you want to perform any operations, then you need an operator. We have three words. We basically have the two words. First one is the operand and another one is the operator. Understand these two words carefully. First, I want to calculate the 25 plus 2. I want to do this calculation. So on which I am performing the operation. That means I am performing the operation on 25 and on 2. So this is called as a operand. Operands. Whatever the operation I am performing, that is called as an operator. Okay. So basically, whatever the operation I am performing, that can be called as an operator. Operator can be of multiple type: plus, minus, multiplication, subtraction, division. So all along with that, we are having the multiple types as well. So we are going to discuss the different types of operator in this part. And operands are on which I am performing the operation. Okay. So now these operators are divided into the multiple types. First, there was an operator. Now this operator is divided into the multiple type. First one is the arithmetic operator. Arithmetic operator. Another one is the relational operator. Relational operator. Then third one is the assignment operator. Assignment operator. Another one is logical operator. Logical operator. Then at the fifth number we have the membership operator. Membership operator. Then at the sixth place we are having the identity operator. Identity operator. At the seventh place we are having a bitwise operator. Bitwise operator. Okay. So in arithmetic operator we are having the multiple operations like the plus, minus, multiplication, division, floor division, modulus. Then we are having an exponent. So these are the different operations. These are the different operators inside the arithmetic operator. In relational operator, we are having the different operator that we will discuss later. Relational means equal to, greater than equal to. So these are the relational operators. Okay. An assignment operator means I want to assign some value, that is a equal to sign. That is the assignment operator. Logical operator means AND operator, OR operator, and NOT operator. That is a logical operators. Then we have a membership operator, that is in and not. So these two are called as a membership operator. In identity operator, we are having a is operator and is not operator. We will discuss with the practical implementation as well. In bitwise, we are having a bitwise AND. We are having bitwise OR, bitwise XOR. XOR is denoted with this sign. 1s complement, left shift, right shift. Okay, so these are inside the bitwise operator. Let's start the practical implementation of all these operators. So let's first discuss about the arithmetic operators. Here I am creating a new file, that is operators.py. First, let's discuss about the assignment operator. Arithmetic operator. Let's discuss about the arithmetic operator first. Arithmetic operator. In arithmetic operator, we are having the plus, minus, multiplication, division, floor division, modulus, and print. So here I am using the print statement, that is print 2 plus 5, that is a addition of 2 plus 1 addition, print 2 minus 1 subtraction, print 2 into 3 multiplication, print 4 divided by 2, 4 divided by 2, this is division operator. Then we have a floor division, that means 6, 4 divided by 5 divided by 3. Then we have a 5 divided by 3. Then we have a, now let's first understand about the normal division and the floor division. Floor division means double sign. So let's first execute this file. So if I am executing this file, so for line number 2 I am getting 2 plus 1 3. For line number 3 I am getting 2 plus 2 minus 1 1. For line number 4 I am getting 2 6, and then for line number 5 I am getting 2.0. For line number 6 I am getting the output as 1. Let's understand this thing. Let me first erase this and let me write the same thing, that is 4 divided by 2. Let me execute this again. As you can see, for line number 4 divided by 4, floor division, not divided by, as you can see, for the line number 5 I am getting 2.0, but for the line number 6 I am getting the 2. So the floor division is similar to the normal division, but it always ignores the floating point value. So when I am doing the normal division, I will always get the floating value. That means 0.0, 0.00, 0.3333, 0.0000. So if I am using a floor division, let's consider I don't want the floating point number. If I will divide the 5 by 3, obviously I will get a floating digit. That means I will be having a value, and after that, after point, I will be having some values. So if I want to ignore those values, I can simply use the floor division. Floor division will simply ignore the floating values. Now the another is called as a modulus operator. So this was important, that is floor division. Floor division. Then we have a modulus. Modulus means to find the remainder. Let's consider I want to find the remainder. That means 4 modulus 2. To find the remainder, it is called as a modulus operator. Modulus operator to find the division, to find the remainder of this. So if I will execute this, so if I will divide the 4 by 2, I will get the 0 as the remainder, but if I will do the 4 divided by 3, I will get the 1 as a remainder. Okay, so it helps us to find the remainder. Now the another is called as an exponent operator. Exponent means to calculate the power. If I want to calculate the power, that means power means I want to do the multiplication of 2 3 times. That means 2 into 2 into 2. Calculate the power of a number, we are using an exponent operator to calculate power of a number. Power of a number means that 2 will be multiplied 3 times. That means 2 into 2 into 2. 2 into 2 into 2. 2 to the 4, 4 to the 8. So I will get the 8 as the output. I will execute this. If I'm executing this, I'm getting 8 as outputs. So these are called as a arithmetic operator. Now we are having another kind of operator that is called as a relational operator. Relational operator means whenever you want to compare the two values. So let me first comment all these lines. So here I'm commenting all these lines, and then we are going to discuss about the relational operator. Relational operator. So whenever you want the relation between the two value, you will be using the relational operator, like the greater than, like this one, greater than, less than. Then we have equal to compare to the two value, not equal to, then greater than equal to, then less than equal to. So these are all called as a relational operator. So let me first write up here. I've created a variable a which is storing 10, then the b variable which is storing 20. Now I want to check whether these two values are equal or not. So I will do a equal to b. it is going to compare the A and B. It is going to check whether the A and B are same or not. If it is storing the same value, then I will get the output as true. Otherwise, I will get the output as false. These two values are not same. That's the reason I'm getting the output as false. Then print A greater than B. A is not greater than B. I will get the output as false. A is not greater than B. I will get the output as false. But if I will change this sign to A less than B, obviously I will get the output as true. Okay. So in this way, you can check the relation between the two values. Now we have the assignment operator. Let me first comment all this. Then we are having the assignment operator. Assignment means we want to assign some values. Assignment operator. Assignment operator. So whenever I want to do any assignment, that means A equal to 9. So this is also assignment. I am assigning the value 9 to the A variable. So this is the assignment operator. Then I am having a B variable which is 2. This is also the assignment operator. Now I want to do this like this. A equal to A plus 5. I want to write this statement. That means initial the value of A is 9, and now I want to add 5 value to the A variable. If I will do the print, I will get if I'm printing A, let's see what will happen. I'm getting the output as 14 because initially the value was 9. Now I have added the 5 more to the 9. That's the reason I'm getting the output as 14. So the one way of doing the basically changing the assigning the new value is this. Now the another way is like this. I can write the same statement of the line number 23 in the shorter format. Shorter format means A plus equal to 5. So the line number 23 and 24 both are same, but it is a different way of writing the statement. If I will execute, I will again get the output as 14. Because both are the same statement, but these are two different ways. So let's consider for B variable, I want the multiplication of the B variable with the two values. So I will write B into 2 equal to 2. So I am saying that I want the multiplication of the B value with the 2. Initially it is 2. Now I want to multiply with this 2 value. That is 2 into 2, 4. If I will print B, I will get the 4 as the output. I'm getting the 4 as the output. So this is a different way of writing the line number 23. If I want to write this in this way, I can also write this in this way. B equal to B into 2. So both statements are correct and both statements are same. These are two different ways of writing the code. Now for similarly, you can write for the division, subtraction, multiplication, floor division. You can do all these things for all these operators like plus, minus, multiplication, division, floor division, modulus, exponent. You can write the code in this. This is a shorter way of writing the code. Okay. So this was the assignment operator. Now there is a logical operator. Let me first comment all this. And let's move to the new type of operator that is called as a logical operator. Logical operator means, so in logical operator we are having the three operator: and operator, or operator, and the not operator. And means whenever I am comparing the two values, those two values are true or not. So if any of the value is true, I will get the false. Let me first write the statement. So print, first I am checking true and false. True and false. That means both the condition must be true. First condition is true, but the another condition is false. I am saying first is true and the second is also true. If both the statements are true, in that case the whole statement will true and I will get the output as true. But for this line, I will get the output as false. Because both statements are not true. If I will execute this, I am getting the output as false. Because the whole statement is not getting as true. Because first statement is true, another statement is false. In the similar way, if I will use print statement, I will write true or false. I am saying either the any of the one condition can be true. Either the first condition is true or the second condition true. If any of the one condition is true, in that case, the whole statement must be true. So in this case, I will get the output as true. Okay. So let's do this with one more example. I am saying a equal to 10, b equal to 5, b equal to 4, c equal to 1. Now I am using print. First condition I am checking, a must be greater than 10. Okay. And b must be less than 5, less than 6. A must be greater than 8 and b must be greater than 6. As you can see, first condition is true. That means a is greater than 8 because a is storing a 10 value, but second condition is false. That means b is greater than 6. B is not greater than 6. B is less than 6 because it is storing the 4 value. If I will execute this, I will get the false as the output for the line number 36 because the first condition is true and the another condition is false. But if I will use the same thing for with the or means any of the one condition can be true. So first condition is true, the whole condition will become true. For this, whole condition will become true, but in this, both condition must be true. Okay. So for line number 37, I am getting the true, but for line number 36, I am getting the false as the output. And the not means it is going to reserve the whole thing. Reserve means, let's consider, I will simply I'm simply wrapping this inside the round bracket, and before this I am typing the not. So not is simply going to reserve the condition. If it is a true, it will reserve it to the false. If it is a false, it will reserve it to the true. So for line number 36, initially I was getting the false, but if I will execute this again, I am getting true because due to this not condition, due to this not condition, the whole condition is reserved. It was true, but it was basically false, but now it is turned into the true. Now for this line, I am getting true, but if I will wrap this inside the round bracket and if I will type the not before this, is going to change this true condition to the false. We execute this. There is some syntax error. I have provided I. So if I will execute, I am getting the false because due to the not. So not is going to reserve the condition, reverse the condition. Not is going to reverse the condition. If it is a true, it will become false. If it is a false, it will become true. Then we have the membership operator. So we have till now we have discussed the assignment operator, relation operator, arithmetic operator, relational operator, assignment operator, and logical operator. Let's discuss about the membership operator. Membership means, like in membership operator, we are having the two operator, in and not in. It is a not in operator. Not in. So basically, it is used to check like this. Let me first comment this, and here we are going to discuss about the membership operator. Membership operator. In membership operator, we are having in operator and not in operator. Not in. So first, let's discuss about the in operator. Here I'm creating a list. So in Python, we are having a variable that is a my list. Inside this, I am storing 11, 12, 13, 13, 14, 15. Now I want to check a particular condition. I am saying if number, if 12, I'm saying if 12 is 12 in my list, then print number is present, otherwise not present, else print number is not present, not present. Okay, so let me execute this. I am getting number is present because 12 is present inside the list. But if in case I will change this into not in, I am using not in, so it is going to check whether the 12 is not available. So if I will execute this, I am getting the number is not present because I am checking the reverse condition. 12 is available, but I have used the not in. So that's the reason I'm getting the number is not present. But if I will you remove this not, I will execute this, I will get the number is present. So the membership operator we are simply using to check whether whether the number is present inside list or tuple or any other data type that we will discuss further. But for now, you can simply understand the membership operator, the need of the membership operator. Then we have a identity operator. In identity operator, we are having is or not, is or and is not. So let me first comment this. And we have a identity operator. Identity operator means we want to check the identity is not. Okay. There's a variable that is storing 10, b is storing 10, c is storing 5. Now if I will print a is b or not, a is b or a is b, then print a is c. I will execute this. For line number 51 I am getting true, and for line number 53 I am getting false. The reason we already have discussed. So we discussed, like, whenever we are creating a variable, one memory will be allocated to the 10 value, and the reference of a variable is provided to the 10 value. This we have already discussed, and the reference of b is provided to the 10 value. So the both are referring to the same memory location. That's the reason for the line number 51 we are getting the true as output. But in case of 53, the c variable is stored in the at the another location, another memory location. So it is checking the memory location is same or not. Obviously the memory location is not same for the line number 53. That's the reason I'm getting the false as the output. Okay, this is the identity operator. After identity operator, we are having a bitwise operator. So bitwise operator always works on the bit. So let's consider I want to do the AND operation. Let's understand this. So bitwise operator. So here I want to print the bitwise AND of 7 and 4. 7 and 4. I want to do the bitwise operation on 7 and 4. So how the task will implement? First, the 7 will be converted into the binary value. The binary value of the 7 is 0, 1, 1, 1. Then the 4 will be converted into the binary value. The value of the 4 is 0, 1, 0, 0. And the AND operation will be performed. AND operation we have already discussed that any of the condition is true. If both the conditions are true, only in that case the whole result will become true. And we have discussed over here. This is the AND. And we have discussed while discussing the logical operator. That means both the conditions are true. Only in that case the whole condition will become true. So in this case, the first condition for this line, that is 1 and 0. One condition is true, one condition is false. The result will become 0, 0. But in this both conditions are true, I will get 1. And for this I will get 0. So as you can see, this is the 4. So for this particular line I will get the output as 4. First, when I am doing the addition, when I am doing the bitwise operator, bitwise ends, this is called as a bitwise end. When I am doing the bitwise end operation on 7 and 4, first the 7 is getting converted into the binary value, then the 4 is getting converted into the binary value, and after that the end operation is performed. And the end operation says whenever both the conditions are true, in that particular case the whole condition will become true, otherwise the condition will become false. So I have implemented this and I am getting the output as 0, 0, 1, 0, 0, and the value, the decimal value for 0, 1, 0, 0 is 4. In the similar way, we are having the bitwise OR, bitwise XOR. So these are the different operators. So bitwise always works on the bit value. Bit value means first the values are converted, decimal values are converted into the, first the decimal are converted into the bit values, and then the operations are performed. So bitwise operator always work on the bits, like the first the decimal value is converted into the bit format and then the operations are performed. So we are done with this particular module.